Okay, so we try to finish it. So in, from page 22, okay, so we talk about the detail about FASTER RCNN and the paper. That is the original paper. So original. So important one is region proposal network. And the loss function. This is the result. Result pretty good. Okay. So FASTER RCNN is important. Okay. So again, we do classification, we also do bounding box. And before, in year 2013, they have a paper called ZFNet. And this ZFNet, because it's very early, so they will do the downsampling and classification. But it's not famous. Okay. Year 2013. Around here. So it's because VGG16 is famous than that one. So people talk about VGG16. We almost all know that one. This one. Okay, so we almost doesn't talk about this one, but actually here before VGG we already talked about 5+3 here, but we don't talk too much about it. XNet. XNet has they changed to XNet 21. So XNet is year 2012, and after XNet, here they changed the filter from 11x11 to 7x7. Okay, and then they also in the convolution 3, 5, they have more filters, more results. Just give you an idea. And then after that, we have VGG. So VGG has better result. Okay, like this one. But remember, the red one is a maximum purity. It doesn't count a layer. The red color one, the maximum purity for downsampling, so it won't count a layer. So total is 13. And 13 include 5. Actually, I should say include 13 as a 5 maximum pooling, but this 5 doesn't count it 13 because 13 can be 5 maximum. And finally, have a three connected there. That's a VG talk a lot. And here we all talk about the RCNN before. And this is a first RCNN point. This first RCNN we already mentioned. And then after first RCNN, for the first RCN we will include the region. Sorry, I'm not. For the first has no region proposal. Is use a computer vision for using a selective search. But FASTER, they solve the problem of FAST. So they use RPN here. Okay. So here we say the drawback for the FAST RCN is because it's slow. Why? Why it's slow? Because they use computer vision do first. and then deep learning. So it's slow. Okay. So faster, they directly use region proposal, so it's become faster, very faster. So that being faster. So that's what I say. So what's the faster RCNN that combine two network? One network is fast, original fast RCNN. The other network is RPN. Okay. But the different things are original. This is just a region. And then extract a feature and do classification. And RPN is input entire image. They do detection. And so they combine together is actually we find out with input image here. And based on this region, and we also got a region, the feature here. So based on region, we try to do classification. So here is more complete network. So this network is more complete. So we have an image here. We do deep learning. We do encoder for feature extraction. And we have two paths. One path is for region proposal to detect the region. And the second is that from this feature, so call the feature here. And this is only region, only the bounding box. So based on the bounding box, we select the interest region and do the classification and do the refinement. So here's fast RCNN. So faster RCNN, we have a region proposal. But after here is a fast. 注意一下 this is a faster RCNN. We draw this way, probably it's still not easy to understand. But we draw this way will be easy for you to understand. So it's meaning here. The input of fast will be a region you are interested. So before this one, we use region proposal to find the region you are interested. So the original image here, we do encoder, downsampling to encoder. So we have a code here, many maps here. Actually, I use this one. This is the same as this one. So original here, we use the VGG16. We do the encoder. We extract a lot of features. So here we have a feature map, a lot of feature map. And this resolution suppose is 7 by 7 by 512. So we have 512 maps. Okay, so based on this one, we input to the region proposal network. And region proposal network, they will they will do the region detection. So two things. They do initial bounding box for interest region detection. Also, they do classification, but the classification only foreground and background. So the output of RPN is a region. It have an initial detection. So output is bounding box only. They don't have a feature. They only have a detect bounding box. So based on the bounding box here, and based on this one, the feature map here, 512 feature map here, and then the input is for each bounding box. 你在这里是只有 RPN 是有把 bounding box， 你把物体侦测到了，只有 bounding box 而已哦。是 RPN 输出只有 bounding box， 还有那个 bounding box 的 confidence 值啊，就是它的信心值。那这边是另外一条路是 feature map， 是原来这7×7的乘512的 map， 你把它过来，然后这个 RPN 是针对这7×7里面哪几个 region 是你有兴趣的，你把它 然后把它丢到这里来。那这里是什么？这里是个 alignment， 就已经丢这个已经出来了。那所以这一块就是这一块。哦，实际上这是 face， 我这写错了，这应该是 face 才对。所以 if 这边是 face 啊，所以你有 bounding box， 你把每个 bounding box normalize，you normalize the bounding box， so we call ROI pooling. So ROI pooling sometimes we also call ROI alignment, and that's the same size. So ROI pooling, this one is similar as very similar to very similar to SPP net because the output will be fixed size. Okay, no matter this suppose this ROI, this output, this is output of a region proposal network, and you have many features. So no matter what kind of a region you input to here, the output size will be the same. Output dimension will be the same. Okay, so here's SPP. Back to here. So here's SPP. We call our pooling or our alignment. And based on it, we input to here. And there's two loss function. And loss function include classification and regression. So this loss function is the same as this loss function, RPN loss function. Two loss functions are the same. So this loss functions are the same as this loss functions. The different thing is that this loss, the total loss here include regression and classification, but RPN the classification only two classes, one big one. The first RCN, the output here, the classification supposes 20 classes. So it's a car, people, cat, dog, something like that. So difference. They also try to refine the region box of the initial result of RPN. Okay, so that's the entire first RCN is this structure. Okay, and even though first RCN is already a little bit old, people still use this one or try to improve this result. So first RCN is still important because the structure is clear, is simple. Okay. And here we just mentioned about this one. So this one, I say this suppose it's 7 by 7 grids. Overall is 512 maps, right? And we do here, what's this one? It's SPP. So after SPP, we fix the size. We have a 4 by 4, 1 by 1, 2 by 2, 4 by 4, and 4, 8 by 8, something like that. 8 by 8. So we have a 256 dimension features, and then we do regression or classification. But important one is anchors. So anchors are very important method for region proposal network. 这个 anchors 很重要，这个概念哦，因为你不晓得物体在哪边，它怎么办？它就创造 anchors， 然后再针对这个 anchors， 每个 anchors 拿出来，去看里面有没有存在物体。所以 region proposal 出来的 detection 出来的结果的 bounding box 不是很准，为什么？因为它用 anchor 来做。 那只是粗略的把那个 bounding box 弄起来。但是 anchor 这里它只比前景跟背景这样子，所以这个 anchor 里面如果没有前景，它就把这个 anchor 拿掉。我每个 grid 有9个anchors，那这 anchors 里面如果是背景，这个 anchor 我就把它去除掉，因为里面没有物体。如果这个 anchor 里面因为有 ground truth， 这 anchor 里面有物体，假设一个人好了，那一个人的比例呢是这个为主，所以9个anchor 里面，每个 grid 9个 anchor 里面，它可能只保留这个 ratio， 其他这2个 ratio 就拿掉了，这 anchor 拿掉了。那另外比例就是假设3:3嘛，这5:5，哎，5:5里面可能这个人还是存在，所以是要保留2个 anchors， 其他9个里面保留2个，其他7个就不见了，是这样子。anchor 是这个意思。它粗略，但它还是有做一点 fine tune， 要把人的位置还是稍微 fine tune 一下这样子。啊，所以 anchor 你这个位置里面，它会有9个 anchor 来看里面有没有你要的物。那每个 grid 都有9个，这样子。啊，这是 anchor 的目的。那我们又从头，刚刚是讲概念，我们又从头再讲更 detail 的东西，就回到那注意的是31页 page 31。This is the entire network, very important. So what we try to explain is based on this network. Okay. Go back to page 33. We say again. So original, we have an image here. But no matter what kind of image size, in this FASTA RCNN, they are normalized to 1000 by 600 pixels. Okay. So they're based on the shorter one. And so shorter one, they will normalize to 600. And the same ratio, they will try to normalize. Okay. And the other important one is that the background thing will become one class. Okay. So suppose they have a 20 classes plus one background class, so total 21 classes. Okay. And here they just tell you we will need to do it. The shorter size will normalize to 600. Okay, that's pre-processing. So after we pre-process, we input to, for example, VGG16. So we have a first block, second block, third and fourth and five blocks. Okay, so after 5 blocks, original VGG16 had 5 blocks and 5 downsampling. But here, some people don't do the last downsampling because they feel 7x7 is too small. So right now, some people use only up to here. They keep after the number 4 downsampling, maximum pooling. They keep do extraction, but in the last one they don't do downsampling. So only 4 downsampling, but they to extract the feature. So final output here become 14 by 14 by 512 maps here. 这最后的 map. From this one, the final output, final encode is this one. So based on this one, we will do the region proposal. Okay. So based on this one, we will do the region proposal here. Okay. Here, the thing is okay. Why is 6 by 40? Why here is this one? No, this is because the original VGG has small size. Original VGG16 has small size. So output here is 14 by 14. But in this case, this large image size. So up to the block 5, they have a 60 by 40. This is original VGG, and this right now. So right now we have a 60 by 40 by 512. Okay, so here it was 60 by 40 by 512. This final output here. And then here they do the convolution for each one. They use small window 3 by 3 by 512. So each one become 1 by 1 by 512. So we have a 2400 vectors here. 你在这里这样做嘛？因为我们后面这里要做什么？因为我们要开始要做 region proposal network. Because we want to do region proposal network for each grid. Region proposal network is for each grid. Here we do one more convolution again. So for each grid, we have a 512 dimension vector. Grid 是以一个 pixel 为单位，所以我们把这个变成再做一次 convolution， 33 convolution 就变成这有60乘40这么多个 grid。好，这是我们要的结果。从这里开始。那 in the second is I think I do zoom in small. In the second one is about the anchors. How do you design the anchor? So we just talk about anchor. Anchor is that we total have 9 anchors because we have 3 scales. Why here is 128 scales? It's not 3 by 3. Why? No, because suppose it's 3 by 3, but this one is low resolution. If this window we map to the original image size here, it will become 128 by 128. So we have 3 scales here, 3 by 3, 5 by 5, 7 by 7. We map the image size will become this one. 注意一下，我们在这个 anchor 这是低解析度下已经当 sample 4次了。那在低解析度下，我们的 ratio 是3比3嘛，5 7比7。但是这个大小，我们如果把它 map 到原来的影像大小，变成这样子，让你容易了解。那原来影像大小的 pixel size 就变成这样子，128，对不对？256 12，跟你本来是1000乘600多，1000乘600哦，所以那张是大影像。你要找这里面到底有没有存在物体嘛？那 your ratio 是 3 times ratio 这样子。Okay, so totally you find out totally you have a 21,600 anchors in this one. Your total anchors is large. But for the first RCNN, we ignore the cross-boundary anchors. That's meaning when your anchor is beyond the boundary, we delete it. So finally, they still have a lot. Finally, we have 6,000 anchors. 我们只要 anchor 超出 boundary 这个 anchor 我们就不理它。可你这样子的话，你可能从2万多个 anchor 就变成6000个 anchor 这样子，还是很多。那我们再从这个 anchor 里面去找里面有没有 candidate， 这样可以哦。我这边为什么讲那么慢？是因为那个 bounding box 我们一定会用到，常常用到，这比较实用。那你会遇到这些问题，这样子。好，再继续。那所以你现在有6000个哦，6000个 anchor 了，有不同比例的有6000个。那你要记得哦，每个 anchor 里面是每个 anchor 是这种 grid 哦，所以在这里的 anchor 是这个每个 anchor 嘛，这是 grid， 所以有这些资讯，就刚刚讲的，你的 anchor 你的 anchor 最后是变成这种 dimension。And then you will do classification and regression. So this is loss function. So your loss function is here. One is the regression. The other is the classification. So your total loss is here. So for the region proportional network, your total loss is classification and then regression. Classification is foreground, background. Regression is for the bounding box. Okay, so classification is more easier. So even foreground here. And before we talk about cross entropy, because classification, so we use the cross entropy. And cross entropy, we use P star log P. P star is the ground truth, 1 or 0. P is the estimation result, prediction result. But before our cross entropy without this term, but that's not good. This one is better because our cross entropy, we consider not only the foreground, we also need to consider the background loss function. So this is for, suppose this one, this will be 0. So when you detect the foreground, you also consider background. When you detect the background, you also consider the foreground, both. So this is better. So cross entropy. And the other important thing is how do you define positive foreground and define negative? Negative here for the bounding box. When you detect the object, okay. So for the bounding box, if your bounding box overlap with your ground truth, the area IOU interest of the unit, we call IOU. This one IOU interest of intersection of unit 交集分支连集 intersection of unit 就是交集分支连集。如果这面积大于0.7，我们就称为 overlap 很大嘛，就称为1 label 成1。如果小于0.3，我们就 label 成0。中间介于0.3跟0.7，我们就不要理它。This is important. Before, I mean, this is training. So sometimes we training is this one. For example, suppose IOU is 0.6 with label 1. Below 0.6 with label to 0. But that's not good. Here they have 3 concerns. One is positive, the other negative. Label 0. Other is I don't care. They don't care. Not concern. Why? Because this one will confuse. Okay. So for the training, they don't want to have a confused things. That's their issue. But is this one a good one? 这是好的吗？它对吗？你要去想这件事情。他为了避免 confuse， 他把中间这种模糊地带的东西，他把它拿掉了。啊，这 training， 可是这是对吗？这是要注意哦，这对不对？它是这个做出来结果有比较好，但是反过来讲，这个 case 叫什么 case？ 这个 case 叫 hard hard case. Right now, the many papers start to concentrate on this case, the hard case, because hard case is easy confused case. Actually, easy confused case is important case. So the idea, the concept is from supportive vector machine. Supportive vector machine is think about what? Margin. The margin, we talk about underfitting, overfitting, right? So we talk about that one, overfitting problems. So the same thing, should we care about this one? That's important. OK， 这很重要哦。 这篇很多人是把这个忽略掉，那这个忽略掉的东西我们叫 hard case。那 hard case 到底要不要忽略掉？这很重要。那现在很多人把 hard case 拿回来，为什么？因为 supportive weighted machine 讲说，我如果有办法把 hard case 把它分得越好的话 ，easy case 一定好。就那 supportive weighted machine 那边那 margin 的观念，所以这个不一定对哦。但他的 case 是研究是说这样会比较好，他已经证明这个比较好，他有证明比较好。但是你先记着说，我讲是这个要考虑一下，好，因为这是属于 confuse hard case。那我们回到这一边 ，so for the classification foreground background they use closed entropy, so there's no problem here. Okay, and then normalize this batch size, and this regression, and then normalize by anchors this difference. The regression they normalize by the anchors because they feel that I only care about the foreground object. So they normalize by this one. And one more scaling term. That's what I say. Here, because this is a discrete, this is continue. Your total loss function you cannot class together. One is a discrete, one is a continue. So they must have a because they different unit. The unit difference. Because this is between 0 and 1. This is not. We hope this unit will be the same as this unit for the total loss. So they have a scaling term here. And right now the new paper try to deal with this one. 新的 paper 有开始解决这个，因为你这个目前这个方法哈，就是旧的方法就是你去猜啦，给他1，给他2，给他3，给他4，看哪个结果最好。所以这是猜出来的，所以你就通常是拿着照用，这样子。但是这才是一个问题，因为不容易猜。然后你的 case 跟我的 case 不一样，我的拿你的 case 来用，我不一定对，所以这个 scaling term 是一个问题，怎么给是一个问题。好，那回到这一边，那是 regression。So this is regression. Okay, we talk about this one first. So what's the loss function for regression? Is this function? And what is this function? This function is 大概讲一下 is this one, page 37. And this is also important. Many people use this one. So this one we call the smooth L1 function for regression. Okay, so if let's mean this one. 下面这个哈 ，so original L1 is this one. Smooth L1 is this is straight. Smooth is here. So smooth L1 is here. So this regression they combine two equations. The first one is absolute. So this is this one. Go from here. So if this is result, output result is this one. Input is x is here. Output is here. So here is meaning what? Meaning if the x value is bigger than 1, this one here, the green color, bigger than 1, so it will be linear. So this will be linear. But when it is a smaller than 1, will become curve, become smooth, more smooth. Why? Because we do gradient descent. Gradient descent cannot derive on here. 就是因为这是这种很垂直尖的角落，尖的角落这 gradient descent 是等于0了，没办法就微分就0了。因为你用 gradient descent 来做这个直接转角这地方没办法做微分，你只能用这种曲线是慢 b b b 嘛，因为 gradient 是 b b 也慢，所以你只有这种属于克服的东西才能逼近。所以这一段就是小于当 x 在正负1中间的时候， 你要用这个用这个 x 平方这个 curve。那0.5只是说，因为这curve 你这然后在 y 轴，这是0.5，所以乘以0.5。所以你在这一段的时候要用这个方程式，在这一段以外要用 L1 这个，用这个下面这个式子，这样子。所以这个还蛮常被拿来用，就拿来用。但是自己注意，这物理意义就是刚刚讲的，因为我全部用 L1 来做的话，这里微分会出状况，因为不可为，这也不可为，不是我刚刚讲错，是不可为，因为那个 discrete 这个没办法为，所以你用curve 来为，所以它有这种条件状况，那就 smooth L1。那这我们常会拿来 regression， 就拿来用就好了。那回到刚刚这边，所以这个式子就是刚刚讲 regression loss function 在这里。那再就是我们来讲，那 what's this one？ So basically, regression has a center xy with wh. Okay, and you have a what? You have a this one, and then you have prediction is this prediction is meaning estimation. So estimate, and A is mean anchor, and ground truth is star. Okay, so what we try to estimate T will include X, Y, W, and H. Okay, but the problem is here because cross entropy, the output value between 0 and 1. Regression, the output is between 0 and infinity. So the unit is different. So what can we do? We will try to do normalization. So our normalization, the unit will be WA. So because our anchor is fixed, our anchor box is fixed, the size is fixed. So based on the anchor will become our denominator term. 因为我们的 anchor 固定 size 嘛，所以它可以当一个标准，所以它当分母。那我们在估，这是一个 ground truth 值嘛，那这是估计值。So ground truth is the same. Estimate ground truth minus anchor divided by anchor the same. X, Y is the same. And then the WH are the same. So they divided by anchor. So the same as estimation, we do the same this one. So our denominator term is the anchor. 就变成有个标准在那边。那这个值就虽然不会介于0到1之间，但是它会把它变成介于，实际上是介于 anchor 那个 anchor 角度的正负这边这样移动这样子。OK， 好，那大概这边大概是那为什么取 locus 所了解是为了正值啊？它值是正的，这边大概这样子。This is for region proportional network. Go to next page. So continue. That's the definition for the loss function. So the region proportional network here. Okay. So the output is this one. Our output is the XYWH. Our class is only foreground object and background, not object. Okay. So we only use VGG16, but we also use extraction. So we take 13 layers for extraction. Okay, and here is a region, normalize, and do classification. So the region proportional network, the same as previous one. and it's smooth. 要继续。After you do previous one, this is still region proposal network. I would like to introduce one we call non-maximal separation. This is also important. I summarize. When you go back, you can check this one. I summarize here for the training. And training has two methods. One is page 41, the other page 42 for the training process. So first one is you do RPN and faster. RPN and faster is first method. The second method is combined together. You have 4 laws. One is a region proposal network. The second loss is a fast RCNN, but all has a classification and regression. 这个注意一下哦，这个你如果回去，我今天讲的，因为讲比较慢，但是我怕你搞混了。最后这里41页跟42页帮你整理，你可以回去先看一下这个。就说事实上，我们这个 network fast RCNN 基本上我刚刚一直强调有2个 network， 一个是 region proposal， 一个是 fast RCN 2个 network。那你最后你看你的 training 上有2个方法来做 training， 那这很重要，你去参考一下。一个是独立，我先 train RPN， 再 train fast RCNN， 再交叉 train 这样子。第二个是我一起做 training， 但我要强调是说，它事实上我就讲它有2个 network， 每个 network 又有2个 loss function， 每个 network 有2个 loss function， 但是2个 loss function 又长得就几乎一模一样，一个是 classification， 一个是那个 regression， 所以这是 proposal 的 network， 这是 fast 的 network， 这样子。好，所以注意一下，它总共有4个 loss function。好，那在讲我刚刚讲到现在是帮你再稍微整理一下这样子。那我们回到刚刚，那刚刚这2个 loss function， 这2个都会用到 non-maximal。为什么 ？When you do the bounding box detection, you will need to use non-maximal suppression。你只要用到那个 bounding box， 一定会用到 non-maximal suppression。为什么 ？When you do the detection, if the object is here, there are many candidates will surround the object. Okay. Any target is foreground or object is there. When you do scan line, and you close to the object, it should has many object and many candidate bounding box there. So how can we combine become only one bounding box? We call not maximal suppression. It means if it's not maximal, we will delete it. If it is not the maximum confidence value, we will delete it. So this is example this one. So the first one is this one. Step is here. 步骤在这里。So the first one is suppose because each bounding box we have a confidence value. Whether it's foreground, background, that's classification. For each bounding box we have a confidence value. It's classification for either foreground or background. That's your confidence value. So if confidence value in this case is less than 0.6, we delete it because it's not foreground, it's background. So first of all, if confidence value of foreground background classification, the value is less than suppose 0.6, we delete it. Okay, but 0.6 you define， 上不一定是0.6，是你要靠经验去取。那再来是根据这个0.6以上 ，we do sorting。Okay, so after we sort the entire bounding box, we pick out the first one. So if the first one is 0.9, we will select which one is 0.9. I zoom in more. Okay. So we pick out the 0.9. So here we find, oh, 0.9 is here. Okay, so we select the 0.9, this bounding box, pick it up. So we pick up the box with the highest PC, this is confidence value. So we pick up this one. And then next one is any overlap bounding box with this highest one. Suppose in this case we have a 0.6, 0.6 and 0.7. We delete it. We delete any bounding box overlap with the highest bounding box. We delete it. Okay. So finally, we have in this region, we only have one bounding box. That's your target. And then second one is still, you try to pick up the second largest confidence value. So you find out the second largest confidence value here, 0.8. And the same, any overlap region with this one, we delete it. So suppose this only one is 0.7, we delete it. So finally, we have a 2 bounding box. This will be your final result. Okay, but in our experience, this is incorrect. In our experience this way, 我们的经验是这个不大对哦，哈，就是说 you do that, for example, after you remove the value below 0.6, fine, and we pick out the maximum one, suppose 0.9, and we remove this one. We remove the overlap region with 0.9, but be careful. Sometimes if the overlap region, suppose it's only 10%, sometimes we need to keep it. So we only delete the large overlap region with the highest score. If overlap region is smaller, sometimes we need to keep it because it's very possible is suppose I do face detection. Sometimes there is a face here. So your bounding box sometimes will overlap. Okay, because occlusion. So if you delete any overlap region, you will delete some bounding box because occluded. 你不要就这个做不是很好。我们经验是说，你不是说只要有 overlap 要把它杀掉，不对哦。因为有时候你我刚刚讲错，是假设你要 detect 一个人的身体嘛，对不对？那因为你是有 perspective 的关系，可能有个人在你后面这里，他被你遮住了，然后有一部分还存在。那这我们两个人的 overlap region 就会比较小。那你有把所有的 overlap region 的物体都杀掉的时候，这种 occlusion 的物体就会被你杀掉了。所以我们通常会把 occlusion 这种 overlap region 如果是小的话，我们不杀，我们只杀掉 overlap region 大的，把它杀掉。overlap region 小的我们要保留下来，然后继续做下来，不然你会杀掉太多会被 occlusion 的物体这样。OK， 那这个是那个很重要的叫 NMS non-maximal suppression。那这个不止一个方法，也不会很多，就有几个方法，有不同的方法。哦，你再去看，因为有时候还考虑到中心点的位置，每个 bounding box 中心点的位置，因为这个还蛮粗的，这是一个，因为刚开始出这个 paper， 那这个事实上还不那么完全，后面有几个方，我这边没讲。那有些方还考虑到中心点，那这个好像我下次再。Next week I will finish this, because I almost done. I almost done. I will finish this one. So 2 weeks later, okay, don't come here. 2 weeks later, I will talk with you in the internet. I will mainly talk about mask RCN. It's very similar to first RCN, and then talk about YOLO V4 and many YOLO V4 ideas from here. But they use the two features. YOLO V4 has two features. One, sorry, darknet. Sorry, three features. Darknet, feature peanut network, and PNet. But feature peanut network is not their method, and PNet is not their method. Okay, but CPS darknet, that's their method. Okay, so we'll talk about that one 2 weeks later. Okay, and next week we'll talk about we'll check your project with your PPT. Okay, so that's it for today's lecture. Thank you，谢谢你们，就这样啊，有没有问题？这回去要看哦，这个哎呀，Best RCN 啊，好，谢谢你们，辛苦了。